Hi, I'm Kevin Keller, the pragmatic statistician. In this episode of Street Stats, we're going to talk about using the X moving range chart in almost every case. Now, wait a minute. In class, we learned a whole bunch of different SPC charts for discrete data as well as continuous data. Why did they teach us a whole bunch of charts when one would do? The simple answer is statisticians got involved. Why they got involved is they wanted to map out the exact error rate. Now, if you know the distribution of the data, you can create exact limits. And they work out well for manufacturing because these error rates balance out the risks in taking action versus not taking action. You were taught SPC charts as if you were going to actively add observations, like in manufacturing, to control the process. Now, if you're doing a chart a single time, the X moving range chart is quite robust. Even if you're keeping the chart up to date, it works most of the time. Let's take the case of binomial data. That's data that is either good or bad. It's binary. If you tracked yield or defect rates, you're working with binomial data. Product is good, product is bad. Now, in your academic classes, you have been given a condition that said you might assume normality if n times p and n times 1 minus p is greater than or equal to 5. If the phrase normal approximation to the binomial gives you post-traumatic stress disorder, you were taught this concept. Now let's look at that. So if we had a case in which we had an error rate or a defect rate of 0.05 and 100, what this little piece of software gives me is the probability distribution function for a binomial in which we have a probability of 0.05 and a sample size of 100, which if we multiply n times p, we would get 5, n times 1 minus p, we would get 95. And you can see that the distribution of probabilities is actually pretty close to normal. If we increase that further to go to 0.06, we can see it's getting more normal. We get up to 0.1, and it's quite normally distributed. So what would happen if we went down? We might have 0.04. So now we're starting to get pretty skewed. So if we have a reasonable n times p or n times 1 minus p, if both of those are greater than 5, then we're in great shape. So let's go look at Poisson. With Poisson, I've got an average of 5, and you can see it's tiny bit skewed, but not too bad. If I increase it up to 8, you can see it's quite symmetric, quite normally distributed. If I go down to 4, again, it starts getting a little bit skewed, but it's not too bad. So with both count data as well as good versus bad, we're in great shape to use an X moving range chart. Now, you could probably get away with 4 or 5 or lower, but we often use an X moving range chart with continuous data that isn't normally distributed. It ends up that the X moving range chart is quite robust to normality. Normality is not an assumption to use SPC, despite many myths to the contrary. So here's the skinny. Once we have 5 or more possible values for any data set, the X moving range chart starts to be available for any sort of data. Now, rare events have their own set of charts. 5 is the magic number in all situations. 5 possible values. N times p greater than or equal to 5, average of 5 counts. And if you were considering using a U chart or an NP chart, it's even more robust. So, in manufacturing, with continuous data where subgroup sizes are greater than 1, I would always use an X bar and R or X bar S because the variability chart is valuable, sometimes even more valuable. But just in about any other application, likely plotting the average in an X moving range chart is going to answer the question you have. Do you have a day one problem or a recent problem? Plotting the average and assessing whether it is stationary or not does not require the variability chart in many cases. Now, have I used all of these charts in my career? Absolutely. My guidance is this. For ongoing manufacturing control, use the correct chart that you learned in training because the promise of the limits and the associated risk are closest to that promise of plus or minus 3 sigma. But if you're doing a Lean Six Sigma project or simply doing baseline analysis, unless you have rare events, using the X moving range chart is good enough for just about anything. So, the Swiss Army knife of statistical process control. And now you understand why. Why make your life more complex when you're doing a Lean Six Sigma project or doing a one time analysis? Use the X moving range chart with assurance. So be careful out there. The streets are messy and so is data. But remember, there is always a way.